In this video, I'd like to talk about solving systems of equations with the elimination method. So remember, when we're solving a system, we have two different equations and we're trying to figure out what the intersection of these two equations is. Or graphically speaking, we're looking for when do these two lines cross each other? What is this point? So that's the typical case. It's not always the case. Sometimes you have parallel lines that do not intersect. Sometimes you have the same line, though they might look different. Maybe one's a multiple of each other or of the other one. And if you have the same line, then you essentially have one line on top of the other line, and they intersect at every point. So you get infinite solutions. But this is the typical case where they just cross in one point, and we want to find the x and the y values of that one point. So there are several ways to solve these. You can solve it by graphing, though honestly, if the answers are not whole numbers, then graphing is probably the worst choice because it's just hard to interpret the graph and know exactly which point it is. We could also use the substitution method, which is where you solve for one of the variables and then plug it into the other equation. You are able to reduce it to an equation with one variable. You find the one variable, and then you plug in that variable to the other equation, and you can find the second one. So that's substitution. Now elimination is where we're going to extend on that combining equations exercise. So let me rewrite these. 3x plus 8y is 15, and we have that 2x minus 8y is 10. So the elimination method is essentially where we're going to either add or subtract one equation from another. And the whole idea is to try and eliminate one of these variables, x or y, so that we have an equation with just one variable which we can solve for. So notice that the coefficients on y in these equations are opposite. So if I were to, let's say, add the second equation to the first one, then we line them up by column. So 3x plus 2x, that's just 5x. And here we'd have 8y plus negative 8y, or 8y minus 8y, which would be 0y. And 15 plus 10 would be 25. And notice we have eliminated the y variable, because 0 times anything is 0. And so we have an equation with just x in it. So we can divide by 5 and find that x is 5. So we found one of our coordinate points. We just need to find the y value. And at this point, you can choose either to plug it into this equation or this one. It really doesn't matter. So let's just plug it into the top equation here. So we have that 3 times 5 plus 8y is 15. Notice this is 15, and if we subtract 15 on each side, we get that 8y is 0, or that y is 0. So what we found is that these two lines cross in the point when x is 5 and y is 0. So that's what you'd put in the box. X is 5 and y is 0. So let's do a few more problems of these so we can get some practice. And in most of these, you're just trying to determine which variable should you eliminate. So in this one, minus 5y plus 8x is minus 18. And notice the coefficients on y are opposites. So if they're either opposites or the same, then that's the variable you want to eliminate. So we'd have that 5y plus 2x equals 58. And since they're opposites, if we add them, then that should eliminate the y's, because minus 5y plus 5y would give us our 0y. Let me actually use a different color. And here 8x plus 2x would be 10x, and 58 minus 18 would be 40. Now we can solve for x because we've eliminated the y value. So divide everything by 10, and you get that x is 4. Once you find the x value, then you just pick whatever equation you want, plug in x in the equation, and solve it for y. So we have 5y plus 2 times x, which is 4, equals 58. This is 8, so we got 5y plus 8 is 58. Subtracting 8 on each side, 5y is 50. And dividing by 5, we find that y is 10. So these two lines intersect at the point when x is 4 and y is 10. So let's do another one. And again, it looks like the coefficients on y are opposites, so we want to eliminate the y value. So minus 3y minus 4x equals minus 11. And we have that 3y minus 5x is minus 61. And from here, like I said, we want to eliminate the y values, so we are going to add, since minus 3y plus 3y would be 0y, and minus 4x plus negative 5x would be minus 9x. We're just subtracting. And we have minus 11 minus 61. So that would be minus 72. And so this simplifies. Minus 9x equals minus 72. Divide by negative 9, and you get positive 8. So we have our x value. We're going to plug that in, let's say, to this top equation. Minus 3y minus 4 times x, which is 8, is negative 11. So minus 3y minus 32 is negative 11. And we can add 32. Minus 3y equals minus 11 plus 32, or 32 minus 11 would be 21. And dividing by negative 3 would be negative 7. So we think this goes through at 8 comma minus 7. Now, one way to check that your work is correct, because these are possible to check. It's a little tedious, but you can definitely do it. Go to the other equation and plug in these coordinate points. If you get something that's true, then you know for sure that both of these points do go through the point 8 comma negative 7. Since we already used this one, we plugged in x equals 8 in this one and found y is negative 7. So we know for sure this line goes through this point, but to know for sure that both of them go through that, we just have to check this one. So let's plug in x is 8 and y is negative 7 and see if we get something true. So we get 3 times negative 7 minus 5 times 8 is minus 61. This is minus 21 minus 40. But it's true that when you subtract 40 from negative 21, that you do get negative 61. So this line also went through this point, which helps us feel confident that this is definitely the right answer. So let's do one final question. And notice that the coefficients on x are the same this time. So we have minus 9x. And I should be careful, they're not the same, they're opposite. But it's usually when either they're the same or the opposite that's the variable we want to eliminate. So we have minus 9x minus 6y equals 15. And for the bottom one, we have that 9x minus 10y equals 145. And since they're opposites, if we add them, then the x's will cancel. So we have minus 9x plus 9x, well that's 0x. Minus 6y minus 10y would be minus 16y. And 15 plus 145 would be 160. Divide each side by negative 16, and you get negative 10. So that's our y value. Now we're going to plug that into one of these. Let's just say the top one. So minus 9x minus 6 times negative 10 should be 15. And this is plus 60. So minus 9x plus 60 equals 15. Subtract 60 on each side. And you get minus 45. Divide by negative 9. And you get positive 5. So when x is 5, y is negative 10. But again, we think this is the answer, but we want to make sure. So let's check it. We want to feel very confident that we're doing this correctly. So we're going to go to the equation we didn't use when we plugged in our variable. So this bottom one now, because we used the top one to find the x value. So we use the bottom one to check. So when x is 5, y is negative 10. We'll plug those in. You get 9 times 5 minus 10 times negative 10 equals 145. Well, this is 45, and this is 100. And 45 plus 100 is 145. So we checked it. It did work, which means we can feel very confident that this coordinate point, 5, negative 10, is definitely where these two lines intersect each other.